So, very good morning to you all. I think in last class, so we have discussed about port and port declaration and how to declare the list of ports and no list of ports. These all concepts we have discussed it. Okay. So today what we will do it. So this is a last topic of second model. So this should be we have called it as port connection rules. Okay, so whatever these two concepts we are discussing, these two concepts should be very important for your exam concern. One question should be fixed in your exam for 8 marks. Okay, so explain the port connection rules. Here there are so many rules we will get it whenever we are connecting the ports. Okay, so here I think whenever you have drawn that block diagram, so that in your slide the diagram was there. So by drawing that diagram, you should explain those port connection rules. Okay. So here first, what we need to do it. There are so many ports are there in Verilog. One is input port, output port, in-out port. Okay, input and output are unidirectional, but in-out is a bidirectional port. Okay, so what all are the rules we should follow it? Okay, here, so what we need to do it, so whenever we are designing any circuit or any system, so that system or that circuit should be contains internal ports as well as the external ports. Okay, so whatever information should be there in external, so that information should be transferred to the internal device through the ports. Okay, port is nothing but communication. We are transferring some information. Whatever information should be there externally, so that information should be transferred to the internal. So after that, so depends upon that device internally that will do it, all the operation it will execute it. So depends upon that device will get the output. That output should be transferred to the external. Okay, so here, so whenever we are transferring information to the your device, so what all are the rules we should follow it? How we should connect the internal external input port to the internal port, internal input port. Okay, so those we are called it as port connection rules. In Verilog, we should follow these connection rules. So depends upon these connection rules, we have to do the connections. In your programming, we should follow these are the rules. Okay, so here in your block diagram, you can check it. So I have written 4 connection rules. There are 4 connection rules are there. So first I will explain you about input. How input should be connected externally through the internally. Okay, so whenever we are connecting externally, so at the time that external input, we will write it or we will declare it by using register or otherwise net. That is a data type. That you can declare by using register data type or otherwise net data type. Why we need to declare by using register or net? Net is nothing but wire. Net data type is nothing but wire. So through a wire, we are transferring the information, but we are not storing it. But whenever we use the register data type, we are storing the information. Why input should be declared register or net data type in external? Okay, so first, whenever we are supplying any input information to the your device, so at that time, external information we are transferring that information to the your device. So external input may be register or data type. First, we need to store it or otherwise directly apply that information to the your device. No problem. Okay, so how you require it depends upon that requirements. You should do it. Before you can store it, after storing that information, you should provide to the your device. So at that time, we require register data type. You can declare by using register data type. Or otherwise, sometimes what we will do it, so whenever we are declaring by using register data type, so at that time, what we will do it, so whenever we are declaring by using register data type, so at that time, we require register data type. So at that time, we require register data type. Or otherwise, sometimes what we will do it, so whenever we are declaring by using register data type, so at that time we require register data type. Clear or not? But internally, same port, whenever you are providing internally, so internal input must be net data type. That should not be a register data type. Clear? So internally what we are doing, we are not storing the result. So whatever external information should be comes from the external environment, that should be transferring. So what function we require, what operation we require. So that operation will execute by using that particular device. So after that, so that information should be transferred through a wire. We are not storing result internally. We are not storing. We don't require that result should store on that particular device. Okay. So after that, that we will transfer through a internal port to external port. Okay, internal output port through a external output port. So at that time, so before transferring to the external output port, so first we should store that result on your device. Clear or not? So after storing that result, next we will display it. Next we are displaying. So because of that reason, internal output port must be register or net data type. Check it in your block diagram I have written. Okay, internal output port must be a register or otherwise net data type. But external output must be net data type. Why? We are transferring the information. We are not storing it. Externally, we are not storing. Why? We have to show that whatever output we are getting to the external peoples or external market. We have to show it that whatever result we are getting it. So because of that reason, through a wire we will transfer it. Clear or not? So we are not storing the result externally. So because of that reason, register what? That external output must be a net data type. It should not be a register. We cannot declare it. So because of that reason, whenever we are writing the test bench, you can check it. Whenever we are writing the test bench, so output must be declared by using wires. Wires only we are using. So because of that reason, always what output must be a net data type. Okay, next you should go for in-out, internal in-out declaration and external in-out declaration. Both in-out is nothing but what? When we need to declare the in-out, so whenever we have some information in some devices, so that information we need to transfer to the any other devices. Clear or not? So at that time, so that should be declared by using in-out declaration. Okay, so at that time, so for declaring the in-out, we require wire. Through a wire only we will transfer the information. So because of that reason, so if you are using wire as a name, so that should be, we will call it as net. So because of that reason, external in-out or otherwise internal in-out must be declared by using net data type. Okay, there we are not storing the result. So because of that reason, so in-out that internal in-out or external in-out port must be declared by using net data type. Okay, next these are the three what port connection rules. So that three port connection rules I explained it, and those I have mentioned in your slide also, you can check it. So last one is width matching. What is width matching? It is a legal to connect internal and external port to different sizes, but because synthesis tools could report problems. Okay, here what we are doing, so we are taking the wires, through a wires we are transferring the information to the internal devices, internal components. So at that time, internal wire and external wire size must be same. There is no different sizes. That is, we are called it as width matching. If you use two wire system, you can use two wire only. If you use four wire system, you can use it four wire only. Okay, if you use different size system, we cannot get the output. We'll get a error in the width matching. That is a fourth port connection rules. Okay, so these are 4 port connection rules. You should explain it. Okay, so remember these 4 connection rules. Okay, in your exam you will get explain the port connection rules for 8 marks. Okay, so next we will move to the next concept. So that is uh, unconnected port. What is unconnected ports? Okay, so that name only suggesting. So what is unconnected port? Unconnected is nothing but that is not connected to that gate. So at that time that should be we are calling it as unconnected. Okay, how we need to identify is it unconnected port? Okay, so we will explain with one example how that port we have called it as unconnected. Okay, so Verilog allows port to remain unconnected. For example, certain output port might be a simply for debugger and might not be a interested in connecting them to the external signals. Check it. That should be called it as unconnected. We have given one example. Full adder 4 FE0, so that is the expression. That is the expression we are writing in Verilog. Okay, some expression. Sum is equals to AX or BX or C in that expression we will write it in Verilog in this pattern. Okay, full adder 4 is a what that model name. FE0 is the instance name or block name. So that block we have created. So full adder block we are creating. For that full adder block, there is a 3 input and 1 output I have written in that expression. Okay, but here you can check it. In that output port, C underscore out is unconnected. Okay, so here there are for full adder, there are 3 inputs and 2 outputs, but that block another one output is not connected. I have not mentioned. So because of that reason, that C underscore out is a unconnected port we will call. If you are not mentioned in your expression, that is not connected. Okay, only we are generating some expression, but we are not return the C out. So because of that reason, C out should be a unconnected port. Okay. So next another one example we will see it, that is a illegal port connection. Okay, some student you have to inform me why that is a illegal port declaration. You should tell me the reason. Okay, I will explain that example. So if it is understood that concept, you should inform what is the reason behind that. Why that should be an illegal port connection. You should give me the reason. Okay, so that model top, I have written model top. So next register 3 down to 0 A comma B. Next register C in register 3 down to 0 sum. So that I have drawn within the rectangular box. So that is he is informing that is an illegal port connection. Why it is an illegal port connection? Anyone can guess what is the reason? Why that syntax should be an illegal port declaration? Anyone guess? Can you tell me the reason why that port declaration is illegal? Mantesh? Why that register 3 down to 0 sum is an illegal port declaration? Anyone? No one? I think 5th B division students are.
Sir,
Hmm?
with the
I,
posters.
I have written that reason also in red pen. I have written the what reason also in your slide. You can read it in red by using red pen. I have written the reason also.
Unconnected.
So here we are writing the test bench. Here we are writing the test bench. So whenever we are writing the test bench, so input should be declared by using what register, but output should be declared by using wires. Just we have discussed. So what all are the outputs are there in your codes? Those outputs should be declared by using wires. Just I have explained about port connection rules. So whenever we are declaring the external port, this one is the external output port, some is the output. Some is the output for full adder. That that is the external output port. External output port must be a net data type. Just only I have given the example in last port connection rules. Is it net data type? Then that should be declared by using wire. That should not be declared by using register. But if it is internal output port, then we will declare by using what wire or otherwise net register. But whenever we are showing to the external environment, so at that time that output must be a net data type. Remember it. That is the reason. Okay, but input should be declared by using, check it here. External input should be declared by using register or net data type I have mentioned. In your last class PPTs, you can check it. Sorry, just within 10 to 15 minutes we have discussed it. That dog you can check it. External input must be net or register data type, but internal input must be a net data type only. I have given with the reason also why that is a net only, why that is a net or register data type only. Okay, so external output must be a net data type. So because of that reason, that is a illegal port declaration. In your exam, for this type of question will appear for 5 marks. Okay, so for some students, so I will ask another one or two questions. So here, I think in your internal exams, have you written internal? All
Yes, sir.
all students have written the internal exams. Verilog HDL.
Yes, sir.
Anyone absent? Anyone absent? No one. Okay. So we'll ask. I think is it 2C or 3C? I don't know exactly. So I asked one question. That type of question will appear in your exam for checking the concentration towards Verilog HDL. How much concept you have or understood? We will check it. Okay, so that question should be what? So I've given 3 to 4 what syntaxes, Verilog syntaxes I have given. So you should find out, is it legal or illegal syntax? If it is illegal, write the reasons. Give the reason why it is illegal. Okay, first you should indicate, is it legal or illegal? If it is illegal, you should give the reason. Why is it illegal? Okay, I think first one I asked, register 3.20A. Is it appeared in your exam? Is it appeared in your exam?
Yes, sir.
Okay. Then register 3.20A. Is it legal or illegal? Register 3.20A. Is it legal or illegal syntax?
Illegal, sir.
Illegal. Okay. Next. Next. Anyone legal?
Illegal, sir.
Illegal. Okay. Next. No one is legal. No one is legal. What about Pavitra Yadav? Pavitra Yadav. Is it legal or illegal? Pavitra?
Illegal.
Illegal. Can you give me the reason why is it illegal? ನಾನು ಲೀಗಲ್ ಅಂತ ಹೇಳ್ತೇನೆ ರೀ. ನಾನು ರೀಸನ್ ಕೊಡ್ತೀನಿ ಯಾಕೆ ಲೀಗಲ್ ಅಂತ ಹೇಳಿ. ನೀವ್ಯಾಕೆ ಇಲ್ಲಿಗಲ್ ಹೇಳಿದ್ರಿ? ಕ್ಯಾನ್ ಯು ಗಿವ್ ಮಿ ದಿ ರೀಸನ್? ಪವಿತ್ರ, ಪ್ರೀತಿ, ಪ್ರೀತಿ ಪಾಟೀಲ್, Preeti Patil.
Yes, sir.
Why that register 3 down to 0 A is illegal or legal?
It is illegal, sir.
It is legal. Why it is legal? Can you give me the reason? ಇಲ್ಲೇ ಗೊತ್ತಾಗುತ್ತಾ ನೀವು ಈ ಕ್ವಶನ್ ಆನ್ಸರ್ ಮಾಡೋದ್ರಾಗ ನೀವು ಕರೆಕ್ಟ್ ಆಗಿ ನಿಮಗೆ ವೆರಿಲಾಗ್ ತಿಳಿದೈತೆ ಇಲ್ಲೋ. ಸಿಂಪಲ್ ಕ್ವಶನ್ಸ್, ದಿಸ್ ಆಲ್ ಆರ್ ದಿ ಸಿಂಪಲ್. ಇಟ್ ವಿಲ್ ಟೇಕ್ ವಿತ್ ಇನ್ ನ್ಯಾನೋ ಸೆಕೆಂಡ್ ವಿ ವಿಲ್ ಆನ್ಸರ್ ಇಟ್. ಇಲ್ಲಿ ನಿಮ್ ನಾಲೆಜು ಗೊತ್ತಾಗುತ್ತಾ, ನಿಮ್ಮ ಮೈಂಡು ಎಷ್ಟು ಓಡಕತ್ತೈತಿ, ಲಾಜಿಕಲಿ ನಿಮ್ ಮೈಂಡ್ ಫಿಟ್ ಐತಿಲ್ಲೋ, ಲಾಜಿಕಲಿ ಎನಲೈಸಿಂಗ್ ಪವರ್ ನಿಮ್ ಮೈಂಡ್ ಅಲ್ಲಿ ಐತಿಲ್ಲೋ, ಲಾಜಿಕಲಿ ನಿಮ್ ತಲೆ ಓಡ್ಸಕತ್ತಿರಲ್ಲೋ, ಎಲ್ಲಾನು ಗೊತ್ತಾಗುತ್ತಾ ಈ ಕ್ವಶನ್ ಅಲ್ಲಿ. ಮಾಂತೇಶ್,
Yes, sir.
ಹಾ, ಟೆಲ್ ಮಿ ದಿ ರೀಸನ್ ವೈ ಇಟ್ ಈಸ್ ಇಲ್ಲಿಗಲ್.
That Ariji you have written in uppercase letters.
Very good, very good. Yes, that is the reason. So I think in many classes I said it. So always the keywords are lowercase. Always whatever keywords we are using in Verilog HDL, all must be a lowercase letters. But R I have written uppercase. EG I have written lowercase. But whole that word must be what? Lowercase. So because of that is the reason. So because of that reason, that syntax should be illegal. No one has written. So maximum students, what you have written, A is not a output. That is the reason. A is not a output. Maximum students has written. So because of that reason, who all are attended that question, so your mark is very less in internal exams. Okay, so which one should be second one? Which one is second one? I think another one question should be appeared. Yes, last one. Model. Last, I think third one is model. Is it legal or illegal?
Illegal.
Malikarjun.
Yes,
Illegal?
sir. Illegal.
Why? Why?
So syntax for model should be small letter, sir, but it's a capital
Yes,
letter M.
yes. Okay, so in Verilog, very good. In Verilog, whenever we are writing any code should start with model as a predefined word. But model, we have suggested that is a keyword. If it is started with which all are fixed words are there, those all we are calling it as a keywords. Keywords are fixed words. We cannot change it. User cannot change it. So because of that reason, all keywords must be in lowercase. So because of that reason, model is a keyword. But in your question paper, you can check it. I have written first alphabet letter is capital. So because of that reason, so that is illegal. Here there is no server sign destination. So don't compare with your microprocessor. Such instruction we cannot get it here. Okay, so same thing here, register 3 down to 0 sum I have written. So because of that reason, always register what output should not be a register data type. Always your external output must be what? Net data type. So because of that reason, so that should be declared by using wire. Whenever we are writing test bench, you can check it. Only we are using what register and wires. Input should be declared by using what register data type. So because of that reason, this one is a reason. In your lab, Viva will get a question. In your lab, Viva will get a question. Why input should be declared by using register? Why not by using wire? Why output is declared by using what wire? Why not by using register? So at that time, with reason you should explain it by port connection rules. Port connection rules is a what explanation, just a reason for that declaration. Okay, so we'll move to the next concept. So next concept is I think hierarchical names. Before that, I think another one concept is there. Yes. So that is connecting ports to external signals. This also this question is also appeared in your exam. How ports are connected to the external signals? Okay. So here in this concept, so external signals be connected to the ports in two types. Okay, so in terms of two types, we are connecting it. Okay, so first type we have called it as connecting by ordered list, and another one is connecting by names. This is a two types. By using these two types, we are connecting what your ports to a external signals. We'll go in depth with the first way, so that is connecting by ordered list. What is connecting by ordered list? Okay, so we'll give one example. So with that example, we will explain it. So that name only suggests you connecting by order. Okay, so whenever we'll take one example. Whenever we are designing a full adder, full adder. So first we will draw the block diagram. So for that block diagram, we will, after drawing the block diagram, we will apply the inputs. So whenever we are applying the inputs for full adder, there is a three inputs. So because of that reason, we will give you A, B, C. In which way we have given it, in which way we have declared it, in that order only we should write it in your program. That is, we have called it as connecting by ordered list. In which way you have connected in your program, in your designing, in which way you have connected, in that way only we should write it in your program. Okay, so that is, we have called it as connecting by ordered list. Okay, I think that sentence I have mentioned in your slide. So these signals to be connected must appear in the model's instance in the same orders as the part in the port list into the model definition. Okay, so whenever we are writing the model definition, what is the model definition? That model underscore name. So within the bracket, we will write it all the input, output, and in outputs. In which way, whenever we are defining that model definition within the bracket, in which way we have written it. First, you have written inputs. Second, you have written outputs. Next, in outs, if you have written it. In which way we have written it, same way we should write it in port declaration. So that should be, we have called it as ordered list. Okay, so we have given one example. So that example of 4-bit full adder. Okay, so model top. So I have given here we are writing the stimulus test bench. So model top, that is an example for no list of ports. There is no list of ports in the model top. Okay, so after that, next I have given register 3 down to 0 A comma B. So here we are writing 4-bit full adder. So A and B both are 4-bit wide. So because of that reason, we have written it. Next, register C in. Next, wire 3 down to 0 sum. Check it here in this example. We have written output should be declared by using wires. That is net data type. So wire C out, full adder, FA ordered. Okay, sum C out. Next, first here you can check it. Input should be how, in which way, in which order we have declared it. First we have declared A, B. Next we have declared C in. So because of that reason, A, B, C in. Whenever we are writing that expression, first compulsory, first we should write it output only. Which output? First we have declared it sum. So because of that reason, sum I have written. In this order only we should write it. This one should be, we have called it as connecting by ordered list. Okay, so within the model definition or within the declaration, which one you have mentioned first, so that one only we should write it. So that should bring, we have called it as connecting by ordered list. Okay, so after that we will move to the next second step, that is connecting by names. Okay, so connecting by names. Another one example also I mentioned in the slide. You can go through that example. Okay, next, connecting by port name. Okay, so whenever we are designing any circuits in logical design, so at that time those inputs should be declared by using some names. Okay, that name we should write it in our programs. Okay, so that should be we are called it as connecting by port names. I have given an example in your slide. You can check it. Full ladder fa underscore by name. Okay, see out. So in external port, I have called it as C out. Internal also I have called it as C out. By name only we have called it. By name only we have mentioned that in your program. Okay, so this one should be we have called it as connecting by port name. Okay, next this one should be a last concept of second model. This one should be hierarchical names. Okay, I think this concept we have studied it. That is design methodology. Design methodology. Here we should, same we should draw it first flowchart. Same flowchart we should draw it. So after that we should give some namings. That should be called as hierarchical names. Okay, in which way we have drawn that flowchart. In that way only we should provide the names. Okay, how we should provide the names? The name should be provided with dot symbol. Dot. Remember that a hierarchical name is a list of identifiers separated by dots for each level of hierarchy. Okay, so here I have drawn some hierarchy of SR latch. I think in last class we have discussed about SR latch program, and also we have written a SR latch test bench. Okay, so we have written model stimulus first. We will write a model stimulus. So because of that reason, I have drawn that within the rectangular box. We should draw the flow chart. We should not write the test bench. Okay, we should not write the program. Depends upon that program. We should draw the what flow chart hierarchy. Okay, so first we are writing the stimulus. For that stimulus, we have some variables. We are using some variables. Okay, here we are writing SR latch. For SR latch, we are using four variables. One is set, reset, and q bar. So because of that reason, we have written it at the right side. Next, at the left side, you can check it. So we have written SR underscore latch M1. So we are invoking the SR latch program. So you can check the test bench of SR latch. In that test bench, so first three lines. First line should be a what model stimulus. Second line should be a port declaration. Third line is also port declaration. But fourth line is what you are invoking your code into the what test bench. SR underscore latch M1 within the bracket we have written output and inputs. Okay, so that I have drawn here. So for writing the SR latch, so which gates we require it? For creating SR latch, we require two NAND gates. For that two NAND gates, we require two blocks. So first block I have called it as N1, second block we have called it as N2. Okay, so here you can check it. I will show that code also. I think in last class we have explained it. Yes. So this one you can check it. This one you can check it. So this test bench I have written, I have drawn in terms of flowchart. So first you can check it. First syntax model top. That one should be I called it as a model stimulus. So I have written in first block model that is a stimulus. Next q bar reset is a variables. Four variables are there. Four variables I have written it here. In your what flowchart. Okay, so next fourth line you can check it in your fourth line is uh, fourth line should be SR underscore latch M1. Here you can check it fourth line SR underscore latch M1 Q bar etc. etc. So that I have written here at the left side, left block. Okay, for creating the SR latch, so we require two NAND gates. In your code you can check it. Two NAND gates we require it. Two NAND gate. Yeah, two NAND gates. N1 and N2. In your diagram also you can check it. Two NAND gate. So that NAND gate I call it as N1 and N2. Okay, for creating N1, so which are the variables we have applied it, and for creating N2, which are the variables we have applied it, write it in next block. So that one only I have written N1, N2. So after writing that SR line, so we require Q bar S, comma R are the signals. This one we should write it. For after drawing this flow chart, next we should provide the names. How we should provide it? By using dot. That should be separated by using dot. Okay, so here I have given it. You can check it. In this slide you can check it. First I have written stimulus, yes, that is a name, stimulus. Next, for that stimulus we have applied some variables. So first variable should be q. So because of that reason, stimulus dot q, second name stimulus dot q I have written it. Next variable is stimulus dot q bar. This one is the naming. Next stimulus dot set. Next stimulus dot result. Next, all variables are over. So after all are over, next M1 block. Come for M1 block. How we should write it? Stimulus dot M1. Stimulus dot M1. For that M1 block, which all are the signals should be connected. Those names we should provide it. Stimulus dot M1 dot Q. Stimulus M1 dot Q. Stimulus M1 dot Q bar. Stimulus M1 dot S. These are the namings. We should provide it. Next, stimulus dot n1, stimulus dot n2. Okay, so this should be we have called it as hierarchical names. Okay, or next, by using these hierarchical names, you should draw the flow chart. Reverse also we will get it. Reverse also we will get it. So this one should be we have called it as hierarchical names. Yes, your model 2 is completed. In next class we will discuss about model 3. Okay, so thank you. Thank you.